Hi, I'm Eddie. I'm the Curriculum Architect for the Machine Learning Specialization featuring Andrew Ng. And today I'd like to show you how you actually get those derivatives for the logistic loss function that you see in the first course. And I'd like to tell you beforehand that it's actually super satisfying to see this process of how all these equations simplify into what you see in the course. I hope it's also almost as fun as watching Netflix. So let's get started. Hopefully this may look familiar to you if you took the first course of the machine learning specialization. Here you can see that you are performing gradient descent where you have this cost function here, and you're performing these update steps where you have these derivatives of the cost with respect to Wj and also the derivative of the cost with respect to B. And you were given these expressions in the course. So the question that may arise for you and others is, where do these expressions come from? And so that's the cool part, and that's what we're here to talk about today. First, we're going to talk about how you get the derivative of the cost with respect to Wj, which is essentially how do we get this expression here on the right. So here again is that cost function that you saw in the course. And the question is, how do we get all the way over here, which is this expression right here? So let's start with something a bit simpler. Instead of the cost, which is the sum over all the training examples, let's remember that the inside of the summation, we're calling this the loss on a single training example. And so let's try to solve this first. What is the derivative of the loss with respect to Wj? And it is actually f of x minus y quantity times x. Okay, so let's figure out how we get this. Alright, so let's start with the derivative of the logistic loss function. We have this loss function, which is negative of the quantity of y log f plus 1 minus y times log of 1 minus f. And the goal is to prove that it looks like this in the end. When we take the derivative of that loss with respect to Wj, it'll be f of x minus y quantity times x. So first, just to make this easier to read, when you see f of x, here I'm going to write it just as the variable f to just make it easier for us to manipulate these expressions. So I'm just rewriting it here. So L is minus y quantity times this expression, y log f plus 1 minus y log 1 minus f. Okay. Remember that f defined for logistic regression, f is actually defined as 1 over 1 plus e to the minus z. That's the sigmoid function. And z, what is z? Well, z is the w vector dot product with the x vector plus b, where w is the vector of parameters and x is the vector of features. Okay. When you have that loss defined here, you can actually calculate something really useful, which is the derivative of the loss, not with respect to w right away, but with respect to f of x. So that's this expression here, which we'll show you in subsequent videos. And for this expression, the sigmoid f of x, we can also calculate the derivative of f with respect to z. And in later videos, we'll actually show you that this is f times quantity 1 minus f. Finally, for that z equals expression, we can actually calculate derivative of z with respect to Wj, and we're going to prove that it's actually equal to x sub j. So once we prove all these things, what's really cool is that to calculate what we really want, which is the derivative of the loss with respect to Wj, we can actually take the derivative of the loss with respect to f, multiply it by the derivative of f with respect to z, and multiply that by the derivative of z with respect to Wj. Okay? And this is actually a rule of calculus, which is really useful, but you don't have to study it very deeply for you to understand what's going on here. This is called the chain rule. So if we just take in the expression that we will derive for derivative of loss with respect to f, plug it in there, plug in the derivative of f with respect to z over here, and plug in the derivative of z with respect to Wj over here, and we simplify everything, which I'll also show you in a later video, then you end up with this expression that you see at the bottom, which is what we want. So in the next video, we're going to see how we get the derivative of z with respect to wj to be equal to x sub j. So let's go on to the next video.